So our last topic is graphing from factored form. Factored form is, of course, when you've got a binomial times a binomial to equal the quadratic function. And the first step is to use our zero product property to determine the zeros, or the x-intercepts of the function. So the way that we do that is we set our function equal to 0. Alright, so it says I'm recording. I've got this little paused box in the middle. This program that I'm using does allow me to pause. The last time I paused, the box disappeared. So if you see the box, I'm just going to work around it. I decided to pause the video so that you wouldn't have to wait 3 minutes for me to write that down, but now you have to listen to me for 3 minutes talking about the paused box. So I don't know which one's worse. Alright, so to solve this, we are going to set each term, or each piece that we're multiplying by, equal to 0. That negative coefficient doesn't affect the multiplying to 0 because the opposite of 0 is still 0. So you can either think when you're solving this equation that we're dividing out the negative 1, or because it's not a variable and it can't multiply to 0, we can just ignore it. So I'm going to set each term equal to 0. Alright, so once you set each piece equal to 0, you'll solve those equations to get your x-intercepts. As a reminder, the only way to multiply to 0 is if you are multiplying by 0. So when you look at our original equation, we have 0, if x is -3, times something equals 0. Or if we're thinking about x equaling 1, solving the second one, we have something times 0, which will also equal 0. I recommend once you have your x-intercepts that you write them as ordered pairs. I'm seeing a few students who are getting their x and y intercepts mixed up. So if you write them as ordered pairs, that we solved and got -3 for x, or 1 for x, and we started by substituting 0 for y, then you'll hopefully be better able to graph those, or more accurately graph those. The next piece is to how to find the vertex. You cannot graph a parabola without the vertex. The vertex gives you the turning point of the graph. It's the most important part of the parabola. What's nice for the factored form is that you can just average those zeros you just found to get your axis of symmetry, or the x-coordinate of your vertex. Now take the zeros you actually found, not the values that you see when they're in the equation. So -3 plus 1 all over 2 gives us a -2 divided by 2, or -1. So that's the x-coordinate of the vertex. To get the y-coordinate of the vertex, we're going to substitute -1 back into the function. Alright, so I substituted that value into the function. Evaluating, we get -1 plus 3 is 2, times -2 is -4, times -1 gives us a +4. So our vertex is -1, +4. And then finally, step 3, we're going to substitute 0, that should say substitute 0, in to solve for the y-intercept. Actually, no, sorry, that's the second part of finding the vertex. We can substitute 0 to find the y-intercept as well. That'll just give us an additional point and a little bit more accuracy when we go to graph. So, running out of room here, we're substituting 0 for x. We're going to get 3 times -1 is -3, times -1 is a +3. So make sure you get all this information down. I'm going to have to scroll in order to get to the graph, and the writing will disappear on us again. Alright, so getting all of this information on our graph, we're going to start with those x-intercepts at -3 and +1. And then we had our vertex at -1, +4. And finally our y-intercept was at 3. And we can flip that across the axis of symmetry and get another point over here. Remember to check, our graph is opening down, so we should check and make sure that that matches our equation. Our equation should have a negative coefficient, and it did. We had that negative outside our factored form. All right, moving on to the next graph. Sorry. And we have our final one of the day. We've got the function 3 times the quantity x plus 2, x minus. And I just realized I've been ignoring domain and range on all of these, so we can talk about that on this one, and hopefully the domain and range on the first one was a good start anyway. All right, starting by setting it equal to 0. Once we set it equal to 0, that coefficient of 3, we can think about dividing that out to get rid of it. And then we set each of our two terms equal to 0. So we'll have either our first quantity is 0, and 0 times whatever gives us 0, or our second quantity equals 0, and something times 0 equals 0 to get our two x-intercepts. Solving our first equation, subtracting 2 from each side, and solving our second equation by adding 2 to each side. Again, set these up as ordered pairs so that when you go to graph them, it'll be a little bit easier for you to see. All right, so I got those set up as ordered pairs for us. Next is to find the x-coordinate of the vertex. So again, we're going to average our actual x-intercepts. So we're going to take -2 plus 2 all over 2, which is going to give us 0 divided by 2, or 0. So our vertex will be at x equals 0, and then we're going to substitute that in, we're going to turn this into a g, into our g function to solve for y. So we get 3 times 2 times -2, which will give us a y value of -12. And finally, we can find our y-intercept by substituting 0 in, but that was our vertex, so that doesn't give us any additional points on this one. All right, again, make sure you've got all this information down. I'm going to have to scroll. All right, so to graph, I'm going to count each of these as 2 so that we can fit our vertex on here. So we had x-intercepts at -2 and +2. And then our vertex was at 0, -12. Our graph we're getting to open up, which does match our equation, that 3, that was our lead coefficient, was positive, which means our graph should open up. And again, that 3 is a vertical stretch by 3, so that matches our graph as well. It's really skinny. And finally, here are your two U-Try questions. And I just realized I didn't do domain and range on the last one again, so let's jump back to this one. The vertex, remember, was 0, that's not what I wanted, was 0, -12. So domain for all quadratic functions is all real numbers. The range, I'm just going to go over that real quickly. Our graph opened up, so it was y is greater than or equal to the y-coordinate of your vertex. So again, for the range, if you want to go back and find the range of the examples we've already done, I can go back and do those in class. It will be greater than or equal to the y-coordinate of your vertex if it opens up, and less than or equal to the y-coordinate of your vertex if it opens down. All right, and now here are your U-Try questions. Do the domain and range on each of them, unlike me, and we'll see you in class.